Okay, let's look at differential equations of the form dy over dx equals some function of x. All right, so let's dive right into a couple of examples. All right, so we have differential equation. The reason why it's called a differential equation is that this equation involves a derivative. Right. So we have this differential equation and we want to find the solution. Solution is going to be a function y, right? So let's try to find that. Right, so whenever you have this, it's actually quite easy because all you really have to do is, since derivative is already given as a function of x, we can just take the antiderivative to go back to the original function. So basically what you need to do is you have, in order to find y, you take the integral of f of x with respect to x. Right? So let's do that. Alright, so here's the first example. So you have f of x right here. Right? So in order to find function y, right, all you really have to do is take the antiderivative of both sides. Right? So if you take the antiderivative of the derivative, you're going to get the original function y. That's what we're looking for. And then we take the integral of the right hand side as well. So you have x squared minus x with respect to x. Right? Then this is just a power rule, so we can easily take the antiderivative. Antiderivative of x squared would be x cubed over 3, right? Then antiderivative of negative x is negative x squared over 2, right? Plus some constant c, right? So the solution is y equals cube root, that's not cube root, x to the third power over 3, x cubed over 3, minus x squared over 2, plus some constant c, right? So this kind of, since this is a family of solution with the constant c, this is called the general solution, right? Called the general solution of the differential equation. Right? And the second example, we're looking for a particular solution. The difference is there's an extra condition given here. Right? Right, this guy is called the initial condition. Right, so when you have a differential equation with the initial condition, it is usually called the initial value problem. Just a name, initial value problem. Right, so instead of looking for the general solution of the differential equation, we're looking for a particular solution. So it's going to be a single solution which satisfies this initial condition. Right, so let's do this one. Right, approach is exactly the same, except that we'll be able to find the value of c using the initial condition. All right, so again, we take the integral of both sides. Right, so antiderivative derivative of y would be just going to be y. Right, then we take the antiderivative of negative 2x, right, e to the negative x squared with respect to x. Right, if you're used to it, we can actually find the antiderivative directly from here. Let's use substitution, so it makes it a little bit easier to see. All right, so I'm gonna let u be this guy right here, negative x squared, to simplify it. So I decided to call this guy u. All right, then take the derivative of u with respect to x. We get negative 2x, right? Then take the reciprocal of both sides. We get dx over du, which is equal to 1 over negative 2x, right? Then multiply both sides by du, right? So we get the dx is isolated, which is equal to du over negative 2x. All right, so let's rewrite this integral. All right, so first we have integral, and I'm gonna leave negative 2x as it is because I'll be able to cancel it later. All right, then you have e to the u, so you have e to the u right here. All right, dx, we just found out that it's the same thing as du over negative 2x, which is very convenient here. Du over negative 2x, right? So you can see that there's a negative 2x on top and there's negative 2x on the bottom, so we can cancel that out, right? So if you clean that up, you get integral of simply e to the u du, right? Which gives you e to the u plus some constant c, right? But remember that we cannot leave u as u. U is actually originally negative x squared, so we can put that in to get e to the negative x squared plus some constant c, right? Then we want to figure out the value of this constant c by using this initial condition, right? So let's plug in x equals 0. So y of 0 is going to be e to the negative 0 squared plus c, right? But you can see that e to the 0 is 1, so this guy is actually equal to 1. All right, so this is just 1 plus c, and which is supposed to be 3. All right, so by subtracting 1 from both sides, so I'm gonna do that here. All right, subtracting 1 from both sides, all right, c is going to be equal to 2, right? So therefore we have the complete formula for y, so therefore y is going to be equal to, right, we have e to the negative x squared, right? Then c turned out to be positive 2, so plus 2, right? So this is the solution, particular solution of the differential equation given here. All right, that's it. I hope that this was clear.